So we'll talk about, schematic diagrams.
You
think.
recording.
I believe I am. Yep, I have a little red blinking light. They're used to describe how a circuit works and what the interconnections are, so that somebody can easily reproduce the circuit if somebody else wants to build the same thing or manufacture it. They show the components, they show the interconnection between the components. They use what we call standard symbols, which shows the type of the component, usually the value, and in some cases, the part number. You won't necessarily find all that information. It will depend. This is just a typical schematic, like you might see. In this case, it looks like it's a Arduino type Atmega processor with a serial input on it for USB. So what is the name of an electrical wiring diagram that uses standard component signals?
Charlie.
Charlie.
That was a hard one, wasn't it? Which of the following is accurately represented in electrical schematics?
Delta.
Delta.
See, Delta.
See, we have one Charlie, a couple Charlies, and some deltas.
So we can.
Let's see what it is.
The answer is.
Oh, Charlie.
Internet connections.
False.
It doesn't show
Trick question.
the length of the wires, just where they're connected. And it doesn't show the physical appearance of the component. It uses the schematic representation.
Remember that on a schematic, the layout of the circuit board and the layout of the schematic are for two different purposes. The layout of the schematic is to aid in troubleshooting. So the technician needs to be able to look at it and interpret it and be able to follow it through. But when you go to the circuit card, the rule is real estate. You want to pack the components that you need into the smallest possible package, because you don't want to be having to have a truck to haul around your radio.
Okay, we'll talk about symbols. So in this is one of the FCC diagrams. Component number one is a resistor, which we've talked about, and that's that symbol with the squiggly line. Two is our transistor. In this case, remember, it's a bipolar junction transistor. Three is a lamp, not something you see too often anymore. This would be like a little pilot light, similar to what you see in a non-LED flashlight. And symbol number four is a battery. And we always show the positive side of the battery as the longer horizontal, well, it couldn't be vertical, line, and the shorter one as the negative. And then we have a lot of ground symbols. And sometimes you see those two different ways. And this one, it's kind of showing like it's going to earth ground. Question?
Yes, on number four, the length of the bars, if they were reversed, would that dictate the directional flow of the
Change the polarity.
change the polarity of it,
Yeah.
change the direction?
The longer one is
Always top.
in the standard schematic is always the positive.
So the little one is on
I never
top.
knew that. That's interesting.
Well, it had to be one way or the other, and somebody decided that's the way it is.
So it matters when you draw it.
Yes, it does. Now, usually they'll also put a plus or a minus sign just to make sure.
For people like me.
So what is component 1 in figure T1?
Alpha.
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 Yep. What is component 2 in figure T1?
Transition.
Bravo.
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 Yeah, now these are really going to be hard. What is the function of component 2 in figure T1?
I'm gonna go with Charlie.
Charlie.
Charlie. Control of current. Yes.
That's a good choice. You've chosen wisely.
Diodes, ground side.
So the current coming in through this resistor to the base is going to control the amount of current coming from the battery through the light, through the transistor back to ground. What is component 3 in figure T1?
Charlie.
Lamp.
That was Charlie.
Charlie.
All right. What is component 4 in figure T1?
E.
Delta. Delta.
Delta. Delta.
Okay. Okay, we're going to add some more. Okay, we have an AC power plug, a fuse, a single pole, single throw switch, a transformer, a regular diode, a capacitor. Usually in these standard symbols, this is not a polarized capacitor, which if it was an electrolytic, it would be. But they tend to show one of these plates is curved. I really don't know why, because it doesn't matter which way this capacitor was in the circuit. If you flipped it around, it wouldn't make any difference. So why the symbol is different, I really don't know. We got number 7, which is a resistor again. Number 8, remember, is our LED. So it's a diode symbol with the little arrows showing light coming out. Number 9 is a variable resistor. Remember, we called these also potentiometers. But when we hook it up the way it is here, where this wiper or slider is connected to one end, then it looks like a 2-terminal device that's a variable resistance. We call that a variable resistor. And then we have a Zener diode. And if you remember, I mentioned before, if you operate a diode in reverse at some voltage called the Zener voltage, it will break down and conduct current in the opposite direction. So we use those as a voltage reference source typically. So in this case, say this Zener was say 5 volts. What we're doing in this circuit is we're actually applying power to this transformer. We're rectifying it, filtering it, turning on a LED, and controlling the amount of current out. And this Zener diode in this case is going to limit the voltage to 5 volts. So it's going to assess, in essence, be a very cheap and dirty 5-volt power supply. We talked about the switches a little bit there, and in that one, we only showed a single pole, single throw switch, which is represented this way, sometimes like that, which is more of a indicate a push button type as opposed to a toggle. We'll also have a single pole double throw where I can switch between two circuits. And then you can have a double pole single throw where I'm switching two lines between on and off in the circuit. And a double pole double throw where I'm doing two lines between two different circuits. So which type of switch is represented by component 3 in figure T2?
Alpha.
Alpha.
What is component 4 in figure T2?
Delta.
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 What is, oh, okay. We can use a diode as a, what we call a rectifier, okay, to rectify alternating current into pulsing direct current. And we call that process rectification. And sometimes we refer to the diode as a rectifier. They used to make rectifiers specifically when they made them out of selenium and various things that operated as a diode, where it would conduct in one direction and conduct a lot of power. This little circuit is showing a 60 hertz input signal coming into this through the switch to the transformer. We have a voltage come out of the transformer. It's going to be proportional to the ratio of the windings on the transformer. We're running it through a diode as a rectifier. So across this resistor, we're going to see this waveform where the blue is that the input sine wave and also what's coming out of the transformer. And the yellow or gold is what we're going to see across the resistor. So you're only seeing the positive half of that AC cycle. And because it never crosses zero or changes direction, it's called pulsing DC or varying DC. So we did that with a transformer to, in that case, probably reduce the voltage. And what we have is what we call the turns ratio is the ratio of the number of turns of the primary versus the secondary. And that determines what the output voltage ratio is in that transformer, and conversely, the current ratio. Because we have transformers a passive device, so there's no gain, even though we can put 12 volts into it and get 120 volts out of it. If we had 12 volts in at 1 amp, we had 120 out, we'd have 120 volts out at a tenth of an amp. So the power out is going to be the same as the power in. In the real world, it's be slightly less because there's going to be some loss in this transformer core due to heat. If the turns ratio is such that there's more turns on the secondary winding than on the primary, we call that a step-up transformer, where it will increase the voltage and conversely decrease the current. If it's the opposite and there's less turns on the secondary, we call it a step down transformer. And we'd have higher current, lower voltage. The power has to be the same. If it's a 1-to-1 ratio, we usually call that an isolation transformer, so that there's no direct electrical connection between the primary and secondary. It's strictly due to the magnetic field between the two windings. And it's called mutual inductance.
Are there any practical sources, practical uses for an isolation transformer? Would we just use just a wire between the two?
You use an isolation transformer when you want to separate the input source from the output source. For instance, you might have, well, let's say the input to that transformer is 120 volts AC. So one side of that is connected to ground. If you have something on the output side of that transformer that you do not want connected to ground, where you want a balanced output, and it's isolated from ground, then that's where you would use that as an isolation transformer. You'd still have 120 volts out, but it would not be connected to ground.
Okay.
You'll see it
okay,
a
from
lot in audio PA systems will use isolation transformers for that very purpose, to prevent ground loops and hum coming through the speaker.
Really? Huh.
See it in quite a few cases.
Interesting. Okay, I got the idea. Thank you.
Okay. We did this one, right?
No, we have not.
Okay.
Oh.
What component changes 120 volt AC power to a lower AC voltage for other uses?
Transformer. Bravo.
Bravo.
All right. Which of the following devices or circuits changes an alternating current into a varying direct current signal?
I would go with Bravo.
Alf. Bravo. Bravo.
Are you asking?
Bravo.
I'd say yes. So it's going to pass half of the AC waveform. Okay, what is component number 6 in circuit T2?
Where is 6? Oh, there it is.
Bravo.
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 All right. What is component 8 in circuit T2?
Delta.
Delta.
Okay. What is component 9?
Potentiometer.
Charlie.
Yeah, it's potentiometer, but the way it's hooked up is a variable
Charlie.
resistor. Okay.
I don't know what I did there.
Huh? Okay, in this one we have a capacitor with a line through it showing that it's variable. And you see those not so much anymore, but in earlier radios, that was what was connected to your tuning knob would be a variable capacitor made of metal plates, and one set would rotate in the other, so you'd vary the amount of overlap or the amount of area and vary the capacitance to tune it. 3 is shown as a variable inductor, kind of like our variable resistor. It's an inductor with a slider or wiper that will make contact at positions along the coil. And number 4 is a representation of an antenna. So what is component 3 in circuit T3?
Delta.
Delta.
I guess I gotta turn that off. What is component 4 in circuit T3?
Alpha.
Alpha.
Our antenna. And by the way, what this circuit is a T matching network for the antenna to match the impedance coming in to the impedance of the antenna. And we call it a T because it looks like a T circuit. Okay, so schematic diagrams are used to show the interconnection of components, such as all those below. Transistors control the flow of current, either by voltage or current, depending on the type of transistor. Switches can switch either on or off or between two different circuits. Diodes convert AC, or as a rectifier, can convert AC into pulsing DC. It's still a diode. It's just, we call that process rectification. And a transformer converts AC to a voltage dependent on the turns ratio, anywhere from a step down to an isolation to a step up. And the power in is equal to the power out. So there's no gain on a transformer. It transforms, it doesn't amplify.